Okay, so in this part 3 we will talk about lunar eclipse. So here's a nice full moon, and then as you're watching it you'll start to see the shadow cut across the full moon. So during the night, over a period of time, it will you'll be able to see the shadow of the Earth, basically the Earth's shadow, and you can see the size of the Earth's shadow is massive compared to the moon. So this is not like a solar eclipse. With a lunar eclipse, the shadow of the Earth way more than covers the moon, so it lasts longer than the totality of a solar eclipse, about 4 minutes. This lasts a long time. It's always during a full moon because of you can see how they have to line up, and this is an example of how we knew the Earth was round way before Christopher Columbus's time. So once you get totality, once you get the it wouldn't be called totality. Once you get the full moon completely covered, it will start to go a reddy colour, a copper red or a blood red, which is it's a special thing, and it's to do with the fact that it is blocking out all the light, but the red light bends the most. So the red light bends and hits it goes through our atmosphere from the sun and hits the moon, so it turns it a lovely red colour. But there's a video for you to watch as well which explains that, and you could get asked why that is. And there's that video. Okay, now here's these contact points. In my experience, people will struggle with this, so you're not alone if this doesn't make great sense to you. It's the type of thing I can go over in lesson, but if the moon is travelling from the right to left here, really, you've got the Earth's shadow here, so in this point here it just starts to touch the Earth's shadow. That's what we call first contact. Now when it's finally totally in the Earth's shadow, second contact, there's some contact there. Just as it's touching the outside, the outer end of the shadow, just about to leave the shadow, that's third contact. And then here is fourth contact, and it's now back to its bright full moon. So, how far does it have to go to get across the diameter of the Earth? Well, it's not the first contact to the fourth contact, because that would be the diameter of the Earth plus the diameter of the moon. And this is the bit that might seem a bit tricky. So if you move from here, so if I take the left hand side of the moon, it's now on the right hand side of the Earth, and here the left hand side of the moon is on the left hand side of the Earth. So we've gone from the right hand side of the Earth to the left hand side of the Earth, only looking at the left hand side of the moon. So that would be the diameter of the Earth. So it's from first contact to third contact, it's moved across the diameter of the Earth. Happy to go through that in lessons, and I know the fact that it's not going across the centre of the Earth's shadow seems to complicate things and make it a bit smaller, but we have used that as a calculation for the diameter of the Earth. Okay, so here's a couple of diagrams. Here you can see the moon again on its wobble. It's not perfectly on the ecliptic line, so trying to explain why we don't get a solar eclipse or a lunar eclipse every single month, or every single lunar cycle I should say. And then there's another video for you to watch, which is helping you not mix up solar eclipse and lunar eclipse. Okay, so that is it. So 3 5-minute videos, this being the third, and then you have a number of YouTube videos which will all be attached, all be linked, on class charts, and then there's one worksheet to do. The main thing I want you to get from these videos is just understanding what a solar eclipse is and what a lunar eclipse is, being able to draw a diagram in an exam situation of a lunar eclipse or a solar eclipse. It's just basically drawing 3 circles, getting Earth, Moon and Sun in the right order, and then understanding the terms umbra, penumbra and the different types of eclipses that we talked about and why they occur. And again, it's cropped up in a few lessons, understanding this idea of perihelion, aphelion, and using them to explain why not all the eclipses are the same. Okay, so I hope this has been useful, and just to clarify, any of the trickier stuff using the first, second, third contact, etc., we'll clarify in lessons to try and help you out. Thank you.